All right, welcome back, everybody. Ready for another deep dive?
Absolutely excited to be here.
We're tackling something a little bit crunchy this time, if you catch my drift.
Pretty. Okay, you've
Oh.
got my attention.
Well, listeners sent in a whole bunch of medical stuff, all about broken bones, fractures, the whole 9 yards.
Ah, fractures. Sounds a bit dry at first glance, but trust me, there's a lot more to it than meets the eye.
Hooray. That's what I thought. I mean, a broken bone's a broken bone, right? But digging into these sources, whoa, it's way more complicated.
Absolutely. And honestly, it's something most of us don't think about until we experience it firsthand, or maybe someone close to us does.
Exactly. So this source here, it defines a fracture as an interruption in the continuity of bone and or cartilage. Now, I'm no doctor, but
Yes.
that seems like a mouthful just to say something's broken.
Well, you're not wrong. But that definition actually hints at the complexity we're talking about. It's not just about a clean break, like snapping a twig in half.
Okay, so it's more than just like two pieces.
Way more. The source talks about how the type of fracture depends on things like whether cartilage is involved, how badly the surrounding tissues are damaged, even the force that caused the injury.
Huh, the force. So like a little tap versus, a massive slam.
Exactly. And here's something that really surprised me. Pain, which you'd think would be the biggest giveaway, isn't always a reliable indicator.
Wait, really? If something's broken, it's gotta hurt, right?
You'd think so, but think about little kids. They might not react to a fracture the same way adults do.
Ah, because they don't always understand what's going on.
Exactly. Their pain response can be different, or they might not be able to describe what they're feeling.
That's got to make diagnosis tricky, especially if there are, communication barriers or something.
Absolutely. And misinterpreting those signals could mean a child doesn't get the treatment they need, which could have long-term consequences.
Yikes, that's scary stuff. Makes you realize how important those initial assessments are.
They really are. And speaking of things that make you cringe, the source also dives into fracture dislocations.
Ooh, yeah, those sound nasty. A bone and a joint, double whammy.
Exactly. It's like a two-for-one deal you definitely don't want. The bone breaks and pops out of its joint.
Ouch. Trying to imagine that happening-ish, like something you'd see in a cartoon, but I'm guessing the reality is way less funny.
Not funny at all. And that's why these sources put so much emphasis on understanding the mechanism of the injury.
Mechanism, like how it actually happened.
Exactly. It's about figuring out how the forces acted on the bone, on the joint. It's like trying to solve a 3D puzzle that's gone totally haywire.
Yeah.
Doctors need to know how those pieces were supposed to fit to put them back together correctly.
So it's not just about fixing the break itself, it's understanding the whole story of how it got that way.
Precisely. And sometimes a fracture is a bit like a warning signal. The source talks about something called pathological fractures.
Pathological. Okay, now we're getting into some serious medical jargon.
Basically, these are fractures that happen in bones that are already weakened, often because of some other underlying medical condition.
Like a hairline crack in a bridge. It might not seem like a big deal at first, but it could be a sign of a much bigger problem.
Exactly. The source lists a whole bunch of conditions that can weaken bones. Things like osteogenesis imperfecta, spina bifida, even tumors or infections.
Wow. Okay, so it's not always just about the immediate injury. A broken bone could be a piece of a much larger puzzle.
Exactly. And speaking of puzzles, let's talk about how doctors even figure out what kind of fracture we're dealing with. Turns out there's a whole system for classifying these things.
Okay, fracture classifications. Buckle up, listeners, because it sounds like we're about to get hit with a whole lot of medical terms.
It might seem like a lot, but each classification tells us something important about the fracture, how it happened, how serious it is, and how to treat it.
So it's not just about throwing out fancy words. There's a method to this medical madness.
Absolutely. Think of it like having different tools for different jobs. You wouldn't use a hammer to tighten a screw, right? Same goes for fractures. Each type needs a specific approach.
Okay, that makes sense. So where do we even begin with these classifications? What's the first big distinction?
Well, a good place to start is with complete versus incomplete fractures.
Complete versus incomplete. Okay, I think I can handle that. So complete means the bone's broken all the way through.
You got like a twig snapping cleanly in two.
Ouch, and incomplete. That's when it's not a clean break.
Exactly, more like gunding a green twig. It might splinter or crack, but it doesn't break all the way through.
So are incomplete fractures always less serious than complete ones?
Not necessarily. They can still be pretty painful and require specific treatment depending on the location and the type of fracture, really.
The type. Oh, right, because there are different kinds of incomplete fractures, aren't there? The source mentions a few, like hairline fractures. Those are the tiny cracks, right?
Yep. Hairline, green stick, those are common in kids because their bones are more flexible.
Green stick. That's okay. I have to ask, who comes up with these names? It sounds like something you'd find in a fairy tale.
It does, doesn't it?
Yeah.
But it actually makes sense when you think about it. Imagine trying to break a young green branch. It often bends and splinters instead of snapping cleanly. That's basically what happens in a green stick fracture. The bone bends and cracks but doesn't break all the way through.
Okay, that actually makes a lot of sense. But still, ouch. I imagine it's gotta hurt, even if it's not a complete break. So, besides hairline and green stick, what other types of incomplete fractures are we talking about?
Well, there's also buccal fractures. Those are more common in kids too. Buccal fractures, also known as torus fractures.
Buccal. Torus. Now, those sound like something out of my geometry textbook.
Aha, it's a fitting analogy.
Yeah.
Imagine you have a column, and it's compressed on the top, it buckles outward. That's basically what happens to the bone in a buccal fracture.
Got it. So it's not a break in the sense of snapping, but more of a deformation?
Exactly. Then you have bowing fractures, where the bone actually bends significantly without a clear break.
Bowing, like curving. It's literally bent out of shape.
Yep, that's the one. And what's interesting is that the source points out that bowing fractures can result in a permanent deformation of the bone, which really highlights how important early diagnosis and treatment are, especially in growing children.
Wow. Yeah, I can see how that would be a concern. Okay, so we've covered a lot of ground here with the incomplete fractures. Hairline, green stick, buckle, bowing. Who knew there were so many ways to not quite break a bone?
Right. It's fascinating. But let's shift gears a bit and talk about what happens when things get a little more, shall we say, fragmented. We need to talk about comminuted fractures.
Comminuted. Okay, that one sounds intense.
It can be. Comminuted means the bone has broken into multiple pieces, not just two.
Oh, wow. So instead of two puzzle pieces to put back together, you've got a whole jigsaw puzzle scattered everywhere.
Exactly. And those pieces can be different sizes, some bigger, some smaller, which obviously makes treatment more complex.
Yeah, I can imagine. Okay, so we've talked about complete versus incomplete fractures, but there's another layer to this classification system, right? Something to do with how the bones are situated. The source keeps mentioning displaced versus undisplaced fractures.
You got it. Remember how we were talking about bones needing to stay in their lane?
Right, like cars on the road. Stay in your lane, bones.
Exactly. In an undisplaced fracture, the bone might be cracked or even broken all the way through, but the pieces haven't moved out of alignment. They're still in their lane, but with a displaced fracture.
That's when they decide to switch lanes and cause a pileup.
Something like that. The source talks about how the broken ends of the bone can shift out of their normal position, and it actually gets pretty specific with the types of displacement, which helps doctors determine the best way to put things back together.
Okay, so break it down for me. What kinds of displacements are we talking about here? What do these bone lane changes look like?
Well, we've got things like lateral translation, which is a fancy way of saying the bone has shifted sideways.
So it's slid over like it's trying to make a run for it.
Exactly. Then there's rotation, which means the bone has twisted around its axis.
So like turning a doorknob, but with a bone.
That's a surprisingly accurate way to put it. And then we have angulation. This one's a bit trickier to picture, but imagine two parts of a broken stick, and instead of lining up straight, they're now at an angle to each other.
Okay, I think I'm starting to grasp these bone geometry terms. So we've got lateral translation, rotation, and angulation. Those are some serious bone moves. But how do doctors even begin to figure out what's going on in there? I mean, we talked about x-rays, but are those always the answer?
X-rays are definitely the go-to for diagnosing fractures. They're quick, relatively inexpensive, and they give a good initial view of the bones. The source even mentions how sometimes doctors will use what's called an oblique X-ray.
An oblique x-ray, what's that?
It's basically an X-ray taken from an angle, like instead of straight on. Helps them get a better look at those tricky fractures that might be hiding from a standard view.
Ah, so it's like those Where's Waldo pictures where you have to tilt the book just right to find them.
Exactly. But you're right, X-rays aren't always the be-all and end-all. Sometimes, especially when dealing with more complex fractures or injuries involving the surrounding tissues, doctors might need to bring in the big guns, MRI.
Ah, yes. The MRI, those giant donut-shaped machines that make all those weird noises.
The very same.
Uh,
The source points out that MRIs, while they aren't as good as X-rays at visualizing the actual fracture itself, They're amazing at showing us the surrounding soft tissues, the ligaments, the cartilage, all that good stuff.
So it's like getting a backstage pass to see all the behind-the-scenes action going on around the bone.
Exactly. Gives doctors a much more complete picture of the injury, which helps them figure out the best course of treatment.
Makes sense. But even with all this advanced technology, I imagine there are still cases where diagnosing a fracture is like solving a mystery, right? What happens then?
You're absolutely right. Sometimes, even with x-rays and MRIs, the answer isn't crystal clear. That's when the doctor's experience, their clinical judgment, their intuition really comes into play. The source emphasizes that it can be a bit of detective work, putting together all the pieces of the puzzle.
So it's not just about the technology, it's about the human element too.
Absolutely. And sometimes, the best course of action is simply to wait and see. The source mentions that in some cases, especially with those very subtle fractures, observing how the injury progresses over time can provide valuable clues.
So it's not always about immediate answers. Sometimes it's about being patient, letting the body do its thing.
Exactly.
This has been amazing. I had no idea. There was so much to know about broken bones. It's like a whole hidden world just waiting to be explored.
Right. And I think what's really cool is how this knowledge empowers us. Understanding how these injuries happen and all the different ways they can manifest, it makes us more aware, more proactive about our own health.
I totally agree. A huge thank you to you for taking us on this journey, for unpacking all of this medical jargon and making it, well, dare I say, fascinating.
My pleasure. It's been fun.
And to all our listeners out there, thank you for joining us on this incredible deep dive into the world of bone fractures. Now, before we go, one last thought to chew on. We've talked about all the different ways bones can break, but it makes you wonder, what are the most common causes of these injuries in different age groups? Something to ponder until next time.
Yeah, so lateral translation basically means the bone has shifted sideways.
Okay, so it's like it's trying to make a run for it, slid over a bit.
That's a good way to put it. Then there's rotation, which means, as you might guess, the bone is twisted.
Like around and around?
Yeah, like turning a doorknob, but with a bone.
Ouch. Not a doorknob I want to be messing with. And then there's, oh, what was it? Angulation?
Right, angulation. That one's a little harder to visualize, but imagine if you broke a stick in half, and instead of the two parts lining up straight, they were now at an angle to each other.
Okay, like a crooked picture frame, but with bones. Got it. So we've got sideways, twisting, and angling. That's a lot for doctors to figure out. How do they even know what they're looking at? I mean, we talked about x-rays, but are those always the answer?
X-rays are definitely the workhorse when it comes to diagnosing fractures, yeah. They're quick, they're pretty cheap, and they give a good initial view of the bones. Sometimes, doctors will even use what's called an oblique X-ray to get a clearer picture.
Oblique, another medical term.
Don't worry, it's not as complicated as it sounds. An oblique X-ray is just an X-ray that's taken from an angle instead of straight on. It helps them see fractures that might be hiding from a regular view.
So it's like looking for those hidden images in a magic eye picture. You got to tilt your head just right.
You got it. But you're right, sometimes X-rays aren't enough, especially when we're dealing with more complex fractures or injuries that involve the soft tissues around the bone. In those cases, doctors might need to bring in the big guns.
The big guns, you mean?
MRI, that's right.
Ah, yes, the MRI. The giant donut-shaped machine that everyone's a little bit afraid of.
That's the one. What's interesting is that while MRIs aren't as good as X-rays for seeing the fracture itself, they're amazing at showing us the soft tissues around the bone, the ligaments, the cartilage, all of that.
So it's like getting a backstage pass to see everything that's going on behind the scenes.
Exactly. It helps doctors get a much more complete picture of the injury, which is essential for making the right treatment decisions.
That makes sense. But even with all this technology, I imagine there are still cases where diagnosing a fracture is tricky, right? Like what happens when the X-ray and the MRI don't give a clear answer?
You're right. It doesn't always go exactly to plan. In those cases, it really comes down to the doctor's experience, their clinical judgment, and their ability to, put the pieces together. The source even talks about how it can be a bit like detective work.
So it's not just about the technology, it's about the human element too. Those doctors, they really have to use their brains as much as the machines.
Absolutely. And sometimes, believe it or not, the best course of action is simply to wait.
Wait, you mean do nothing?
Well, Not exactly nothing, but the source does mention that in some cases, especially with very small or subtle fractures, just observing how the injury progresses over time can give doctors valuable clues about how to proceed.
Okay, so patience is a virtue, even when it comes to broken bones.
Exactly. Sometimes the body just needs a little time to reveal what's really going on.
Well, this has been eye-opening. I had no idea there was so much to know about fractures. It's amazing how something that seems so straightforward on the surface can actually be so incredibly complex.
It really is. And you know what? I think the coolest thing about all this is how it empowers us. The more we understand about how our bodies work and how they break, the better equipped we are to take care of ourselves.
Absolutely. A huge thank you to you for joining us on this deep dive, for breaking down all this information and making it, well, not as bone-chilling as I thought it would be.
It's been my pleasure. Thanks for having me.
And to all our listeners out there, thank you for joining us on this journey into the world of broken bones. We hope you learned something new and maybe even gained a newfound appreciation for the incredible strength and resilience of the human skeleton. Until next time.